All right. Thank you, everyone, for joining us for this webinar about the Medical Software and Medical AI program from Yale Medical School. We're so pleased to have you all here. The course will begin in the middle of January. Applications close at the very end of this month of December. So I will share a link in the chat for everyone to go to the applications page. But I give you Professor Zenios Papadimitrios with more information about the program and the requirements. And we're happy to have you all here. Thank you so much.
So I'm going to talk for about 15 minutes or so. I have a presentation. You can hopefully see my slides, and then we'll go from there. So this is the webpage for the program. This is me. I'm a professor at Yale in various departments. This program is offered out of biomedical informatics and data science, so the first department there. AI feels new and it feels like has exploded in the last 2-3 years as a field, but the hype goes back a very long time. This is from the New York Times. This is 1958, and you can read the text that the Navy claimed all the way back then that it's going to build a computer that was going to walk, talk, see, write, and be conscious of existence. It did something very silly, be able to tell between left and right. And you expect to be finished in about a year at about $100,000. So it took us about 70 years, maybe a little bit more to get to ChatGPT, which does some of these things. But as you can see, hype was always there. The real breakthrough was the original deep learning work with convolutional neural networks came out of the Hinton group. This is the famous AlexNet paper on sort of object recognition. And then the big public breakthrough in some ways, if that was a big research breakthrough, a big public breakthrough, is the release of ChatGPT on November 30th, 2022. This is based on some earlier work out of Google that came out in 2017. OpenAI took this and ran. I think it's fair to say Google dropped the ball a little bit here, but they're catching up, it seems, as well. There were 2 Nobel Prizes awarded in this space to 2 of these pioneers of their field, John Hopfield and Geoff Hinton. Hinton, whose group came out with the AlexNet paper. I remember listening to John Hopfield as a young grad student many years ago when nobody thought neural networks were going to go anywhere. And there was a second set of Nobel Prizes for the AlphaFold team that did protein structure. This now is part of Google DeepMind. Hype and overpromise have been around for us forever. On the left is Elon Musk saying we'll have self-driving cars in 2 years. We're getting there. Geoff Hinton, 2016, the radiology will be obsolete in 5 years. And people laugh. This is the cartoon picture we used to show. 2024, radiology is driving in regular cars to work, but by 2025, a lot of them are driving self-driving cars, and many of them are using a lot of AI in their ordinary work. So the field is really happening, even though the hype is probably still excessive. This is an older slide from a little bit ago. This is the first set of AI machine learning enabled devices approved by FDA. You see this near exponential growth. And if we go all the way to 2025, this number is about 1,250. And the majority are in image-related things, mostly radiology and related areas. And this is where things are going in the field. So this is a story of AI, lots of progress, even greater hype over promise. So when we think about AI, when we think about machine learning, really, which is almost a technical term, there is AI that's not machine learning, but for all intents and purposes, the two are synonymous. The field starts out as simple models, something like y equals ax plus b. We design everything. The equation is designed up to a small number of parameters. Is classical machine learning, even linear regression statistics. This is where we were in sort of the 80s and 90s to a large extent. Beginning about 2010s, we have complex task-specific models. This is the current deep learning approaches. These are input-output pairs, good for one task. And now we're in the millions of parameters. And what we have seen in the last, say, 3 or 4 years is these giant foundation models on billions or trillions even of parameters. They're trained on a generic task, guess the next word, guess a masked out part of the image. And these things seem to have emergent properties that can do the work for tasks they were never designed for. So you can see ChatGPT answering all kinds of questions, and they're optionally can be tweaked for specific tasks, prompting, RAG fine-tuning. We'll get into all this later in the program. So when we think about systems, I like to sort of describe systems by analogy to a walled city, and this is my hometown. For those of you who've seen the map before, this is the city of Nicosia in Cyprus, and this is a schematic from Giovanni Commosso from 1570. This is when the walls were completed in the dying days of Venetian rule on the island. And if you look at a walled city, you can think of a system as having an inside, the system, the outside, the environment, and those are separated by a wall. And information goes in and out of the walls through interfaces. So this is from Augusta Gate on the southeastern corner of the city, close to where I grew up, actually. And all information goes through interfaces. So that's a good analogy of that. When we think about AI is just another component in many medical systems. You still have a user interface, you still have databases, you still have firewalls, you still have communication networks, all of those things, but there's also now another component of an AI, something that's something smart, intelligent, what have you. Yeah, but it's still a component of the city. And another way to look at it is to think about engines and cars, perhaps, or think about AI as the engine and think about the system as a car. So that is the picture on the top left. But if you remember nothing from this presentation, users drive the car, not the engine. If you look out your window, you will never see a car. You see an engine driving, you'll see a car. And so the engine is critical, but all sorts of other things, and we all know this when we build these things: brake, seat, comfort, mirrors, user interface, ease of use, documentation, training can affect the user as much as the engine. And similarly, solutions to all these problems of AI, bias, safety, security, may not be solved necessarily by AI, but by other things in the car, better system design. And then, in addition to the car, we have a driver, we have a human in the system. And if we look at the picture on the right, which was generated by generative AI, the question is, where is the wall? Where is the wall city in this picture? Is the wall the system inside the red oval? That's the computer. Or is the wall the yellow box, which includes the human radiologist in this case? And I would like to suggest to you that for most medical AI, the real wall is the yellow box. It's the human plus the computer, because it's really, this is the box that produces the diagnostic result. This is the box that makes up decisions that suggest treatments to the patient. And now we have the environment, the patient, the hospital, the rest of the medical system. If you want to watch more about this, we posted this video earlier this morning. This is the first 6 minutes of the 20 or so hours of the program. This is the link here. It's a QR code. We will share both the link and the actual recording of this webinar in a little bit, so you can get to this and watch like the first 5-6 minutes. This is still a draft version of the video, but this is where we are. Okay, so more about the program. So other things to remember: if a tool is used to diagnose or treat patients, then from a regulatory perspective, it qualifies as a medical device and is subject to review before being able to be sold. The focus of all that review is how the tool will be used, not what it does. What's called the use case. And the key question we have to answer earlier in the process: if something goes wrong, how bad can things get? And that is the risk classification of the device. And we need to be able to demonstrate that we did what we said we did, which leads us to a ton of documentation. And this is part and parcel of the regulated process. Now, the same device could have, if it's used for something different, could have a lower or a higher risk classification. So radiology software that's recommending something may be a medium risk. A radiology software that there's ultimate diagnosis might be a high risk. Nothing about the software has changed, just the use case. So keep that in mind. So a lot of what we'll cover in this course is a little bit of what it would take to use ChatGPT as a medical device. What is the software regulations and processes? How does AI, machine learning, what are the things? How do they work? How do we do validation, clinical validation? How do we integrate the software? And we'll talk about some example clinical applications, both in radiology and beyond. We'll also talk a couple of recent works out of Yale. This is a generative medical model based on event records from the electronic health record that predicts future health events. This is work done by my colleague Andrew Loza, primarily at Yale, the developer of the model. There's a large team from Microsoft Epic that put it together. Dr. Loza will be presenting for us week 7 and 8 of the program. And here's another piece of work came from Yale. This is led by Li Shuang, who you'll hear from in week 15. This is the first review of ambient AI. These are sort of software runs on a phone that generates the first draft of patient visit notes that gets incorporated into electronic health record, edited by a doctor and submitted. So these are sort of cutting edge work here. The outline of the program, you can see it here. We'll have 4 parts: an introduction to AI, a little bit of medical software with AI, and then we'll talk about applications. So the first module, introduction, you can see the topics: some systems theory, some probability, a lot of data challenges, a little bit of regulatory issues. The second module will talk about machine learning, starting with classical all the way to generative models. Module C will talk a little bit about software engineering with AI, some of the regulatory aspects, cybersecurity, privacy, data management. And then we'll conclude with bigger topics, explainability, transparency, bias, and some of the emerging regulations. And in the last thing, 4 weeks, we'll do the applications, first imaging, then clinical decision support. We'll do a quick tour of current and emerging applications, and then I'll give an overall summary at the end. This is how this program will work. We'll have an hour of pre-recorded lectures, an accompanying multiple choice quiz due on the Monday, and we'll do live Zoom sessions on Tuesdays, probably noon and 8 p.m. New York time, and this tend to accommodate most time zones we've had. Last year, we had students from San Diego to Sri Lanka, so that's kind of the span we hope to have. And this is the schedule. You can see we'll release the first videos January 21st. We'll have the first Zoom session January 27th. We'll have 4 weeks a week off, 4 weeks a week off, all the way to June 2nd. There are also a set of supplementary interview videos on our YouTube channel from experts in the field. Some of this, you'll see some of these clips in the actual lecture videos, but you can see the whole video there. This is what a typical week of the program looked like. You'll get an email from me saying, in addition to the videos, here's some supplemental interviews, here's some papers you could read, and just to see the discussion. This is our YouTube channel. You can find more information and different programs here as well. And this is the list of interviews under the podcast link there. In addition, the ancestor of this program is a freely available class on medical software that we recorded. Abigail, who's on the call, introduced us, was the program manager for that program too, on medical software. This is an old screenshot, and all the videos are now on YouTube. You can learn more on this webpage, medsoftbook.com. And a lot of this, there was a companion textbook that came out around that time as well. And so the class and the textbook were companions. The book was written just before the current AI explosion, so it carries a lot of the traditional software techniques, but a little bit of AI. Here's how the admissions process works. We use a rolling admissions process. We did the first review in early December and made the first offers. We'll probably do another one in the next few days. The final deadline is December 31st. All applications that request financial aid will have a small amount of that money for that. We'll review all of that right after the holidays to allow for a more equitable process. And, for more information, this is the webpage for the program. This is the QR code, this is the URL, and this is the intro video that I reported a little bit before.